we are going to discuss a chapter which is known as mole concept. So it's very interesting chapter of first chapter of class 11. In NCERT we'll see the name of the chapter is given some basic concept in chemistry. Now some basic concept in chemistry is basically a revision chapter which deals with so many things like equivalent weight, like mole concept, stoichiometrical calculations, limiting reagent, empirical formula and calculations. So many things assimilated, gathered, and it's basically a recap chapter, revision chapter, basically you can say. So there are few segments of this chapter. So the first topic today we are going to discuss is mole concept. One by one, step by step we will discuss. The first one we are going to discuss is mole concept. So from class 10th level syllabus, you have already an idea about what is mole. What do you think about mole? What is exactly mole stands for? Now see, mole is defined in different angle itself. Sometimes it is defined in context of mass. If rather say that molecular mass means 1 mole of substance, molecular mass generally will express in capital M. Okay, if we rather express mole in context of volume, then definitely it should be a gaseous object like oxygen, like nitrogen, maybe chlorine or any other gaseous object at NTP. You all know what is NTP, normal temperature and pressure. Sometimes it is written as standard temperature and pressure, STP also. So what is that? Temperature and pressure. Normal temperature means 0 degree Celsius or 273 Kelvin, and normal pressure means 1 atmosphere pressure, that is 76 centimeter of mercury. So at NTP, if any of the gases, if we are considering that this is a mole, then it will be 22.4 liter or 22,400 cc or ml, whatever you can say, means 1 mole. So this is another context of mole. And if we think regarding the number of particles, then 6.023 10 to the power 23, it's a known figure for you. 6.023 10 to the power 23, this much number of molecules means 1 mole. So let's discuss in this point that whenever we require the mass to mole relation, then we will discuss that molecular mass means 1 mole. When we are requiring the molecules, number of particles, molecules, atoms or whatever relating to mole, then 6.023 10 to the power 23 means 1 mole. If it is a gaseous object, specifically gaseous object, any gas, not only oxygen, nitrogen and chlorine, any of the gas, then 22.4 liter or 22,400 cc means 1 mole. Okay. Now suppose I have purchased 1 or 2 gas chamber like this. Every chamber is nothing but 22.4 liter. 2 or 3 chamber I have purchased. Alright. Now in one gas chamber I am inserting chlorine gas. The volume of all the 3 chambers are equal. Please do remind this. Here I am inserting oxygen gas. Here I am inserting hydrogen as for example. Alright. Now at NTP, what NTP I have already told you, this temperature and this pressure is nothing but NTP or STP. Okay. Now at NTP, if I ask you that how many number of particles are there, the question is very easy. You can jolly well relate these two relations, that at NTP 22.4 liter of substance, that is the gas substance, means 1 mole, and if 1 mole means 6.023 10 to the power 23 number of molecules, then 6.023 10 to the power 23 molecules will occupy 22.4 liter volume at NTP, or at NTP if the volume of a gas is 22.4 liter, and if I ask you that how many number of particles are there, the answer is in your hand, 6.023 10 to the power 23. Okay. Now if we want to correlate with the number of molecules with the mass, then what will happen? Simply like a unitary method will write 6.023 10 to the power 23, this much number of molecules will be having mass, that is the molecular mass. If one molecule consisting of how much mass, you can easily find out of that. Now mass to volume, volume to number, and number to mass, these three relations jolly well can be understood by this relation what I have drawn in the board. It's simply like a flow chart, and if you go through details of this, then you can find out the relation and you can interconvert these three: moles, number of molecules, volume if it is a gaseous, and the molecular mass. You can correlate, you can interconvert each and everything into each other. Alright. Now see, if I ask you that what is the volume of these three, we will see that the volume is constant for the three gas chambers. Everyone is nothing but 22.4 liter. But number of molecules, what are same and what are not equal in these three cases? This is case 1, this is case 2, and this is case 3. Suppose, imagine. Now what are equals and what are not equal in these cases? Equal is number of volume. You can see here the volume is 22.4 liter. Here also the volume is 22.4 liter, and here also 22.4 liter. Number of molecules at NTP, every mole consisting of same number of particles, that is 6.023 10 to the power 23. So here also number of molecules, and here oxygen molecules, and here chlorine molecules, each and every cases will be consisting with the same number of molecules, that is Avogadro number 6.023 10 to the power 23. But the difference is there in the molecular mass. Okay. Now oxygen's molecular mass, generally if we express in gram, then it is 32 gram. If it is chlorine, if we express the molecular mass into gram, then it is 71 gram. If it is hydrogen, then preciously this is 2.016, or roughly we can say this is 2 gram. Okay. Now I asked you a question that what are similar and what are dissimilar in these three cases. The dissimilar is nothing but the weight of the gas chambers. This gas chamber will definitely weight as 2 gram only. This will weight as 32 gram only, and this will weight 71 gram only if I express in gram. Okay. So number of molecules may seem at NTP. Volume, if all three are gases, then may same at NTP. The dissimilar object is, the dissimilar point is the molecular mass, because their density is different. Someone is heavier, someone is lighter. Suppose there are 3 classrooms. Each and every classroom may have maximum 100 students capacity. Okay. Each and every classroom is having students but of different age group or different class. The first classroom is having the playgroup students, number 100. The second classroom is having the class 10th level students. How many number? 100. And the third classroom, there are also having 100 students, but they are suppose university students or research scholar. Now if I ask you the same question as this one, that what are the similarity and what are the dissimilarity of these three cases, then your answer will be, so the number of students are same, the playgroup students, they are also student, the university research scholar, they are also student. So the number of students are same, the size of the classrooms are also same, but the weight of the classroom after having the student inside are different, because each and every students of different classes matters in their weight. So here also the picture is clear now in front of you. The most important thing, this is already known to you, As per my concept in class 10th level, 9th level, you have already a clear picture about the concept of mole. Now the fact is you need to convert each and everything. Suppose I am asking you that what is the weight of one oxygen? What will be your answer? Simply one oxygen's weight. Now generally the student give a wrong answer that, sir, you have written 32 gram, that means the oxygen molecule is having a weight 32 gram. No my dear, 1 mole oxygen is having a weight 32 gram. Therefore I can write that total 6.023 10 to the power 23, this much of oxygen particle is having a weight 32 gram. Therefore only one particle of oxygen, this will having a weight 32 by 6.023 10 to the power 23, this much of gram. Now suppose I am not interested in oxygen, I am interested in chlorine, then what will happen? The same equation, the same relation, but the value of oxygen 32 will be changed to 71 because the weight of chlorine is 71. Now see, I will write 6.023 10 to the power 23, this much of chlorine molecules, this will be having weight 71 gram because this is 1 mole, this is 1 mole, 1 mole correlates with 1 mole, 1 chlorine molecule will be having weight 71 by Avogadro number 6.023 10 to the power 23. Now question arises that everywhere we can see this Avogadro number in the denominator. Isn't it? Here also, here also. The case changes in the numerator. In case of oxygen, it is 32. In case of chlorine, it is 71. So let us do something, that is 32 multiplied by 1 by Avogadro number. I am writing Avogadro number as Na. Can I write it? 1 by Avogadro number. So this is being expressed as 32 multiplied by 1 by Avogadro number. This is being expressed as 71 multiplied by 1 by Avogadro number. I am just rearranging this, nothing else. Okay. Now 1 by Avogadro number is common for everywhere. This 1 by Avogadro number, this portion is, if you calculate, it will come 1.66 10 to the power minus 24. As I have expressed it in gram, then that will be definitely gram. 1.66 10 to the power minus 24 gram. Now the situation changes. What will be the situation? If I ask you that what is the exact mass of one chlorine molecule, what is the exact mass of one hydrogen molecule, then you will simply put the molecular mass, that is 2, multiplied by the common factor, that is 1.66 10 to the power minus 24. If I am expressing this in gram. Okay. Now this 1.66 10 to the power minus 24, this common factor, this has been known as 1 AMU, atomic mass unit. Clear? So now onward we are going to express the weight of molecule in AMU, atomic mass unit. Now what will be the weight of one hydrogen molecule? 2 AMU. What is the weight of one chlorine molecule? 71 AMU. Okay. Now suppose one student came and asked that, sir, I am not interested in AMU, this atomic mass unit. Forget about atomic mass unit. This gram is very good. I am calculating everything in CGS system, so I need it to convert it into gram. So no worry. Just express AMU as 1.66 10 to the power minus 24. That means substitute this AMU as 1.66 10 to the power 24. Then this is the actual weight of one molecule of hydrogen in gram. This is the actual weight of hydrogen in terms of AMU. Nothing else. That is, this particular portion is 1 AMU. Clear? Now the second very point. Whenever we express this mole concept, generally in the definition it has been said that 6.023 10 to the power 23 number of molecules or atoms or electrons? What does it mean? That means one molecule means one atom. One atom means one electron. Electron is virtually no weight. Basically, it is weightless type of particle. It's so less weight we don't consider. We consider it is negligible in weight. So, what is the magic? What is the chemistry behind this? Generally, when we express the mole concept definition, then regarding the number of molecules, generally we say that this is 6.023 number of atom, 6.023 10 to the power 23 number of molecule, 6.023 10 to the power 23 number of atom, and 6.023 10 to the power 23 number of electron, all are 1 mole. So what is the chemistry, bhai? Molecule does not mean that it is from atom. If this is considered oxygen, then how many molecules are written? 1. Then in one molecule, how many atoms are there? Multiplied by 2. 2 atoms. 1 oxygen. How many electrons? Jolly well you know. Multiplied by 2. You can understand that how many number of electrons. So molecules, atoms, electrons, they are different parameters. How can this be same? Suppose I ask you to count the number of trees. The number of trees and their branches definitely will be unequal. And the number of leaves, these are also unequal. So if I say how many number of trees are there, that much number of branches are there, that much number of leaves are there, they are definitely wrong. No, I am not wrong, because there is a twist. What is the twist behind this? Because whenever we have written the mole concept flowchart previously in the board, perhaps you have noticed that here I have written molecular mass. If you relate molecular mass, then 6.023 10 to the power 23 number of molecules will be correlated with it. If it is atomic mass, then this much number of atoms will be there. Okay. Now this is the fallacy. We do not explain this in details. Generally in the books it's not written clearly. But please do remember that regarding volume there is no fallacy. 22.4 liter at NTP is known as 1 mole. But in case of the weight can be considered as atomic weight and the weight can be considered as molecular weight. If it is molecular weight, then this much number of molecules. If this is atomic weight, then this much number of atoms are there. So this is the interesting part of mole concept. I hope you can understand what is there. Now we will proceed in the problem solving, that how we can correlate in between these 3 parts of volume, number of particles, and mass, that is atomic mass and molecular mass.